let's build a use case for Spark. So basically, the whole story of Hadoop was basically batch processing. So the thing is that, if you look at the whole MapReduce framework, MapReduce really stresses a lot on batch processing. So what happens in batch processing is that the typical scenario is that, I can show you the diagram where typically what happens is, you have the input data. At the bottom, you see the input data, which is coming on day 1, day 2, day 3. And there is always a time lag, when you actually process the data. And this is the typical, shortfall of a batch processing, because, you cannot do it at real time. You can only do it at t+1. So if the event happened at t, you can only do the processing at t+1. And that's the essence of batch processing. Now, it's not that, batch processing is bad, or, it's useless, because there are some scenarios where you would need, batch processing. You cannot do away with batch processing. But again, given the high volume of data and, given the velocity of data, there has been business use cases where you actually need real-time feedback, where, you really cannot rely on, on a time lag, where, say, for example, if you have some kind of a fraud going on in banking transaction, or maybe some kind of a security threat somewhere, any security breach, you need to know it, later on. You need to know it right then and there, rather than, coming to know about it after a couple of days. So given this, nature and the sensitivity of business use cases, there was a need, to come up with, something, which is really real time, where, you can do a lot of stuff, on in real time and get some analytics done. Now, Hadoop, the way MapReduce traditionally works is that MapReduce, you all know, is a very robust batch processing system. It uses a disk a lot, so basically, you have files in the disk, so, it reads it in the memory, and, it does a lot of, map and reduce and shuffling phases. And then again, it puts it back, the mapping data to the disk. Again, it reads, does the shuffling, and a lot of, disk I/O happens. So obviously, wherever, disk input output is, associated, you have a lot of lag. You have a lot of time lag. And so something, the creators of Spark, they wanted something, which is to be very, very fast. And some of the limitations into which they found, when they were doing analysis, of the MapReduce in the mid 2000s, is that, they basically found that, that though MapReduce is a very powerful programming paradigm, the limitations were that, it was very difficult to program, algorithms, which in native code. So because MapReduce was only in Java, so it was very difficult to do any kind of native programming. And obviously, if you had a very small batch, the performance was not very good. It worked very well with large amounts of data. But if you want to do processing in small batch, it actually, was not as fast as people were expecting. And also, it was not very well suited for iterative algorithms. So if you were looking for any kind of machine learning algorithms, where most of them are very iterative in nature, that means, it runs several times to get the correct predictions. So, MapReduce was not very well suited for, iterative algorithms. And it was also not very well suited for asynchronous algorithms. Asynchronous means that, where you event-based, event-based processing. It was not very good for event-based processing either. So in short, the MapReduce was kind of, it was not a kind of silver bullet which people expected. So a lot of companies, took hybrid approach, and, they had their own custom programs to, come over the shortfalls. And that's one of the reasons, why, the creators of Spark started actually thinking in those lines to try to come up with some kind of framework which will help them to make, a robust system. So that's what, that's how Spark came into being. So are you all clear with the use case that, what were the problems, with MapReduce? And please don't think that MapReduce is bad. A lot of people immediately come to the conclusion that, okay, that means, MapReduce is not good. I should not use it. That's not the case. MapReduce is very, very robust. It basically depends on your use case. Okay, so if your use case is correct, MapReduce is still very, very effective. Otherwise, it may not be. So is this all clear to you? Why why MapReduce? What was the shortcoming of MapReduce, and what had to be done to get this going? Okay, Madhukar is asking that is Spark replacing MapReduce framework? No, Madhukar, Spark is not reducing MapReduce framework. MapReduce is going to be there because MapReduce has a very very distinct use case, and obviously it won't be replacing Spark. So it's going to coexist, of course. Anand is saying that can we know more about disk I/O and how Spark does in-memory processing? Yeah, exactly. I mean, the couple of things I just want you to bear in mind is that I'm going to teach you incrementally. So the thing is that when that particular concept is required, I'm just going to give you that particular concept. So don't be in a rush. And so I'll talk all about disk I/O and the Spark architecture when when the opportune time comes. Okay. So Venkat is asking, where is MR more suitable? MR is certainly more suitable if you want to do any kind of offline processing on any kind of data. And if you just want to do some number crunching, and if you just want to do any kind of analysis offline, MapReduce is still much suitable for large data. Yes, Syed is asking, so where does Spark sit on the big data framework? So I'm going to come to that. And so Shankar is asking that is there any use case where MapReduce, which only MapReduce can do and Spark cannot? No, the thing is that you can do both. You can do any kind of analysis both with Spark and with nobody stops you from doing that. It's just that if you want to do batch processing, you should go for MapReduce, and if you want to do any real-time analytics, where you want the results then and there, then you can go for Spark. So it basically depends on what you want to do. Okay. So Spark can be used in almost all use cases where MR can be used. I don't see any difference where MR cannot be used. It's just that you can have. It's quite possible that you can have speed variations. So like Spark will give you the answer much faster than MapReduce. But having said that, given the speed differences, so the job can be done with both. And the in production systems, I have seen production systems where both MapReduce and Spark, they both coexist. And that type of architecture is called a Lambda architecture. Okay. So if you want to know about Lambda architecture where MR and Spark both coexist, so I have a short presentation. You can go to Prithviraj Bose, this thing. You can go to, I'll show you the repository. You can go to Scribbles. Okay, there is a folder called Scribbles. If you go to Scribbles, you will see a PPT called Cloud Computing Architecture. So you can go through this cloud computing architecture. I talk about Lambda and Kappa architectures. So there you can see how MapReduce and all these things coexist. So it's possible to coexist. Okay. Good. So let's move on. So let's look at what Spark is. So Spark, Apache Spark is a general purpose, cluster computing in memory software. It's a framework. So when I say in memory, that means more processing is done in the memory. That doesn't mean that it doesn't use the disk. It uses the disk, but of course, as a programmer, you can choose how much of disk and how much of memory you want, and that we'll see later. When we go to the actual programming stuff, what needs to be done. Okay. So Madhukar is asking that from the hardware perspective, do we need to have higher configurations for Spark than MapReduce because Spark works on in-memory computation? See, the thing is that obviously since it's in memory, you need to have a lot of memory available. Otherwise, Spark is not going to work. But with MapReduce, the thing is that obviously a lot of things can happen on the disk. So obviously you will have a slow program, but ultimately you will get the output. Even with Spark, you can do it with low memory where you can tell Spark to use the disk a lot. But with that kind of thing, obviously you'll have a performance bottleneck. So if you really want fast speed, obviously you should have very high memory. Okay. So obviously memory will be expensive compared to the disk, and obviously if you're working in a cluster, so definitely you will have 150 GB RAM available in your cluster. No, Venkat, see, the thing is that I don't know why you're stuck with this particular point, that you want to replace MapReduce, you want to replace Spark with MapReduce. If you're saying that if I can do everything in Spark, then why I need MapReduce? See, the thing is that it's just like Scala and Java. Like you can do everything in Scala what you can do in Java. Do I really need Java? Because Scala either way is a it's a JVM language. So ultimately everything gets into bytecode. So why do I need Java? Let me get rid of Java. It's not like that. The thing is that the thing is, you have to look into the use case. Like Scala is function programming and Java is object oriented. So you have to see what you want to do. Similarly with Spark, there are distinct use cases which I'm going to discuss later, where you need Spark. Where MapReduce, you cannot do it in real time. So that's why and if you are doing batch processing with Spark, you are just actually wasting your time. Why you want to do that? Because in terms of batch processing, I would really like to have MapReduce, because their APIs are much more well suited for any kind of latent programming. Okay. And I just want to tell you that I won't be doing any comparison, because a lot of people ask me, can you compare say Apache Flink with Apache Spark Streaming, or can you please tell me the difference between Amazon Kinesis versus Spark? See, the thing is that I don't do that, because then you won't be learning anything. I mean, are you here to learn comparisons? Frankly, that you can see it on the internet. You can just do a search and somebody will tell you point wise what are the differences. Okay, so let's learn the fundamentals. It's easy for me. If you want that, I can just keep rambling the differences, but that won't take you anywhere. I don't think you'll be able to clear an interview by answering these questions. Okay, so. Okay, let's kind of get into some serious business now. So the thing is that we know that Apache Spark is in-memory computation system, and it gives you an API in Java, Scala, Python, and R. So you have APIs in 4 languages. You can choose your language you want. The most matured, obviously Scala. The whole Python is written in Scala, and I will tell you also why they chose Scala. When the time comes. And there are also the Python and the R. Python and the R APIs are really catching up with in terms of the Scala APIs. Java, I don't use Java because I don't like the APIs. They're extremely verbose and it's really cumbersome. So my personal recommendation, never use this. I mean, obviously, if the project is using, you don't have a choice. But if you're given a choice, never use this. Always prefer either Scala or Python. And obviously, if you're comfortable with R, you can use R, but you should only use R if you're doing any kind of machine learning. If you're not doing any kind of machine learning in Spark, then don't use R. You're better off with Scala or Python. But if you're doing machine learning, then you can stick to R, because R has a very rich statistics library. So you better stick to that. And even machine learning with Python, there are very good frameworks available for machine learning in Python. So these two, if you're into machine learning, then stick to the Spark APIs for Python and R. And if you're just doing general analytics, then you can stick to the Scala APIs. And if you are the most unluckiest person, then you will probably land up with Java APIs. Okay. And the thing is that you can see, the thing is that if you want to do machine learning, you can directly use the R libraries, but even Spark, is releasing the machine learning on R. So, you more or less get the same power. So, and you can also integrate with your existing R code. So that's the biggest advantage. So if you already have machine learning, code on R, and if you're writing some new module in Spark, so the integration will be faster. Okay. Neeraj, machine learning, I'll do it later on when I have a lecture on machine learning. So let's postpone it for the moment. Okay, so we'll do that when the time comes. Okay, so let's look at the Spark ecosystem. First thing is that let me strike this out. So this is no more relevant. So first we look at the Spark. What it has is, so basically in Spark we have something called the Spark core engine. Okay, so we have something called the Spark core engine. So the Spark core engine is where you have all your core APIs, and then you have the extension modules. So first is basically the Spark core API basically gives you all the standard APIs which you need for cluster computing. And then you have something called Spark SQL, where it gives you interfaces to deal with structured and semi-structured data. So, and gradually Spark is supporting a lot of SQL. So if you want to integrate your structured and semi-structured data and want to fire SQL like queries, so this is the module you should use, Spark SQL. And if you're dealing with streaming data means continuously data feed is coming, like Twitter feeds or or any kind of stock feed or sensor data where data comes continuously. So that's where you can do Spark streaming. So in this course I'm going to cover Spark core engine. I'm going to cover Spark SQL. I'm going to cover Spark streaming, and I'm going to give you introductions on machine learning. So I'll tell you, how you can go about doing machine learning, but we won't go into depth because machine learning is a separate field altogether, where you need years of experience in statistics and other associated algorithms. And then you have something called another module called GraphX, that is basically for graph computation. So graph computation basically means that you must have seen in your LinkedIn or maybe in Facebook, where on LinkedIn, if you go to LinkedIn and say there is Mr. A, so at the sidebar and somewhere in LinkedIn it says that say Mr. A knows Mr. B, who knows Mr. C, and maybe Mr. C can be in your network. So you can say that you can get introduced to A through B and C through. So you must have seen maybe if you go to LinkedIn and search on someone, on the right side you will be able to see such a tree. Which shows that how you can reach A. So these are basically done using graph computations, or you can do also relationship analysis, sentiment analysis. So say for example, if you go to Facebook and see how many likes you have, what are the pages or what are the posts you like, and what are the posts what other people are liking on the Facebook pages. So this kind of analysis, sentiment analysis or relationship analysis, you can do it through GraphX. Okay, and then you have the Spark R library, which is an exclusive library for R on Spark. So that's what these libraries are, and so that's what it explains. And that for the Spark SQL you can use it for structured data and also for semi-structured data, and it is well integrated with Hive. So you can run most of your Hive commands on the Spark SQL. For streaming, Spark streaming, you can do analytical and interactive analysis on streaming data. MLlib, as I told you, is for machine learning algorithms, and it's much faster than Mahout. In MapReduce, you use Mahout framework from Apache. So Mahout is more or less dead now. No more development is happening, and it's much faster than Mahout. So graph computation, as I told you, it's for relationship or sentiment analysis, and R, as I said, is for the R packaging. R packages for from Spark. So is this clear? Do you have any questions on this particular slide? Okay, Anandi is asking that is Spark SQL good for ETL use cases? Yes, it is useful for ETL use cases. I'll show you some ETL use cases when we go to Spark. Okay, they can be used for ETL use cases. Okay, Vijay is asking what are data frames, which is sitting on top of Spark SQL. That I will teach you, when we do Spark SQL. So don't worry about, don't worry about the individual words which you see, because I'm going to cover all of these when we go to the modules. Because now if I just give you the definition, it's a waste of time, because I don't usually give definition. You have to understand the fundamental, what it is doing. Okay. So okay, Prakrut is asking a very interesting question. Prakrut is saying that R already has machine learning algorithms. So why should I use MLlib, for machine learning? That's actually your choice, because again, the question becomes that, it's your choice, that, I still believe that, the machine learning library on R is much more mature than the MLlib. But MLlib is really catching up, so we have to just watch that space of what's happening there. And you can, use the R packages if you already have some R code, and then you can write some Spark R code, to do the integration with the existing machine library, what you have on R. Clear, Prakrut? Okay, Venkat is asking what is BlinkDB. BlinkDB, it's an approximate SQL engine. I don't know why it is here in the first place, because it has nothing to do with Spark. Okay, it has nothing to do with Spark. It's just like I don't know. It's kind of out of place. I don't know why this is here. So BlinkDB is an approximate SQL engine. By approximate SQL engines, I mean that it's basically a trade-off between speed and accuracy. So it gives you the answers very, very fast, with a 99% probability of correctness. So, but that's a different topic altogether. Approximate SQLs. You can just search the net and just see what it means. It's basically a trade-off between speed and accuracy, so that you want fast data, but again with a 99% probability of correctness. And you can actually define the probability of correctness you want. That's called the confidence interval in statistics. So you can just have a look at that. So let's look at, the quick, again, let's quickly rehash. Just remember these things, because, we are not going to cover it again. So, so just keep this in mind, okay? So the Spark core engine is the core engine for the entire Spark framework. So it provides, provide programming APIs to interface with Spark. Then you have Spark SQL, which is used for structured and semi-structured data. And you can expose data sets as tables, and you can fire SQL queries on that, just like any standard SQL. And it's well integrated with Hive. So it's well integrated with Hive. So you can use that Hive queries, existing Hive queries on Spark SQL. Spark streaming, it enables you live streaming of data, to enable processing of live streaming of data. And it's a good alternative to Apache Storm and Apache Flink. Okay, if you know what Apache Storm and Apache Flink is, so, it's a good alternative to that. But there are some cases where Storm, is much better than Spark. So I will discuss that, when the time comes. BlinkDB, again, it's out of place, so let's skip it. MLlib, it's a machine learning library on top of Spark. So it provides, provision for support for machine learning algorithms. And it's much faster, than MapReduce, because MapReduce, as I told you, internally uses the Mahout, APIs. And Mahout, more or less, it's kind of dead. No recent development or contributions are happening to that. And all the Mahout, APIs, all the Mahout algorithms are gradually being ported to the MLlib. Okay. So then we have GraphX. GraphX is the graph computation engine. It's similar to Jira from Apache, and you can do all sorts of, sentiment analysis and, connected analysis on graphs. And the biggest advantage of GraphX is that, you can do it in a very distributed format. So you actually have a distributed graph. I don't know, people who know Neo4j, it's a graph-based database. Neo4j, you must be knowing that, it's not distributed, because there are some architectural problems with Neo4j. But with GraphX, the biggest advantage is that, you can actually have a distributed graph, where you can have distributed graphs in your cluster, and you can do analysis on that we'll see that later when we do graphics, okay? And Shankar is asking, is there any scenario where Spark, streaming and graphics collaborate? See, it's basically, see, Shankar, all these modules are there, they all interact with each other, okay? So I'm going to show you, I have some use cases where I show you that how you can interface, how you can integrate, Spark streaming with Spark SQL, okay? So you have streaming data coming in, and how can you, apply Spark SQL on the streaming data? Similarly, you can, when you have streaming data, and you can also use graphics for, any kind of analysis. So say, for example, you're getting Twitter feeds. So you're getting live Twitter feed, streamed. And you want to do some, sentiment analysis on the feeds which are coming in Twitter based on the users, based on what the hashtags they are following. So obviously here, you have to use graphics to do some kind of quick analysis and get the results. Okay, so these are the kind of scenarios, where you can interface. And similarly for for Spark streaming and Spark SQL. So I have this example where I show you that where I have a stream coming in, a streaming data, and you can actually convert the streaming data on the fly in memory to a schema, and you can do some kind of SQL queries. You can fire SQL queries and get some runtime analytics done on the streaming data. So that more on that when we do streaming. Okay, and then we have Spark R, which is basically the package of R language that enables our users to leverage the Spark power in the R shell. So the thing is that why Spark? So now that now we have a use case, why you would use Spark. So if somebody tomorrow asks you why should you use Spark, your answer should be that the first thing is that it's in memory, because if you want to do some real-time analytics, on data, whether it's streaming data or non-streaming data, Spark is a good alternative because you can get the results then and there, and you can always work on a snapshot of data or the whole data as you want it, compared to MapReduce, which can only happen at a batch level. So that's one. And second thing is that in Spark, you have a variety of libraries available, so you can actually do SQL. It's integrated well with SQL. It's integrated with machine learning, and it's integrated with streaming frameworks as well. So all sorts of data, can be generated, and all sorts of processing can be done. Is this clear why you should use Spark? So tomorrow if somebody asks you why you should use Spark, I hope you can answer this, right? At a high level. Obviously, we don't know Spark yet, but at least at a high level, you will say that, okay, look, I'm learning Spark, but this is what I think. I'll come to, don't worry about what's written in the slide. I'll explain to you all these things, but just whatever I told you, is this clear? Okay, good. So now the thing is that I told you in the beginning of the lecture that don't mess up your learning by comparing Hadoop with with Spark. The thing is that when you run a particular Spark, I'll come to the architecture later on, but just know it for the time being. I'll tell you the detailed architecture later on when we do the Spark architecture. But just for now, you should remember that when you're running a Spark program, okay, you have to run it in a cluster. So you have a cluster of computers which are called nodes. Okay, so you have a cluster of computer, and when you run the Spark program, so it basically the program runs on all the clusters. Okay, all the nodes in the cluster. So the cluster, so the Spark program runs on all the clusters, on the cluster nodes. Okay. And to run it on the cluster node, it uses the cluster manager yarn. Okay, if you're running it on Hadoop, it will be using the cluster manager yarn to do all the resource management. So similarly, if you're running it on Apache Mesos, so it's going to use the cluster manager of Apache Mesos for allocation. So because when the Spark application runs, it obviously, these are applications, it would need operating system resources, threads, heap. So all these things are provided by the cluster manager. Okay, so the cluster manager is like your resource provider to the Spark programs. And if you're running it on Hadoop, so obviously you'll be using the yarn. If you're running it on Apache Mesos, you'll be using the cluster manager of Mesos. Okay, and similarly, Spark also comes with its own cluster manager, which I'm going to show you later. And this cluster manager, is obviously good for testing. Okay, so if you want to just test quickly, you can use the Spark's own cluster manager. Okay, and so is this clear? Somebody asked me that can Spark only run on Hadoop cluster? So Anandi, you asked. So can Spark run only on Hadoop cluster? So you can obviously use other types of cluster managers as well. Nobody stops you from that. Okay. Is this clear, all of you? Is this clear to you? Can you see my screen, folks? I've just can you all see my screen? Okay, and so that's what this particular, that's what we were talking about. And so obviously Spark can be deployed on Apache Mesos, on Apache Hadoop, or on the Yarn cluster, or Spark has its own cluster manager. Okay. And then Spark is obviously polyglot. Polyglot means polyglot in English means a person who speaks several languages. So if you speak say if you speak French, German, English, Spanish, Japanese, Chinese, and as well as your native tongue, so you are a polyglot. So similarly in computer science, polyglot means that several languages. So that means Spark Framework Polyglot means that it supports several languages like Scala, Python, Java, and R. Okay, and obviously it has a very super active community, so they are really marketing it very well. And compared to the number of commits you have compared to other frameworks, Spark is the highest. Okay, and Spark fits pretty well onto the Hadoop ecosystem, but that doesn't mean that Spark only works on Hadoop. Okay, please don't have this misconception. Spark can work on Apache Mesos or Apache Hadoop, and even Amazon S3. Okay. Okay, now I see some questions. Okay, Shankar is asking, doesn't Mesos use HDFS? It can, it may not actually. So it depends on, because HDFS is just a file system. Okay, so it can use it, it may not use it. It's not mandatory. Okay. Anand is saying that, so we need a cluster manager in general. Obviously, without a cluster manager, you cannot run any program in a computer cluster. Okay, so always remember that if you're doing cloud computing, or if you're doing cluster computing, you have to have a cluster manager which is going to manage all the resources and do all the housekeeping for you. You would need a cluster manager to run the program. Okay. Okay. Then next question. So Anandi, I've answered your question, right? Okay. Then we have a question from Venkat. So can we see Spark cluster building in this course? You want to see the Spark cluster building? No, that I cannot show you, Venkat, because I don't have a cluster. I'm teaching you from my laptop. So unfortunately, I do not have a cluster here, but I can show you how to build a cluster. Okay, so that I can show you, but I cannot show you a cluster in function. Is that fair enough, Venkat? So I can show you how to build a cluster, how to what to do where. Those things I can tell you, but I cannot show you a functional cluster. That means like I have 5 nodes working with 200 GB of memory. That I cannot. I don't have the infrastructure here. Prakrut is asking, can I deploy Spark on Windows? No, you can forget Windows, because usually big data doesn't work on Windows, and thankfully it does not, because that's quite a nightmare. Okay. Shankar is asking that, can we run Spark on SGE cluster? What is an SGE cluster, Shankar? Sorry, I don't know what an SGE is. Okay, Anand is saying that, okay, I'm going to do ETL use case using Spark in AWS EC2 cluster machine. Any thoughts on implementations? Yes, you can do that, Anandi. you can jolly well do this on use Spark on Amazon Elastic Cloud Computing. You can do that. Okay. So, but obviously I'm not going to do that because I'm not going to discuss this here because it's very specific use case to you. So we have to discuss this offline. Okay. No, I don't think, Shankar, on the Sun Grid engine, it works. I don't think it supports, Spark supports that particular cluster. You can just check that. Maybe, you have to write some extension to make it work. But as of now, just remember that Sun, it only works on Apache Mesos, on Hadoop, on Amazon, on the Amazon clusters and on the Spark standalone cluster. So only these 4 clusters are supported as of now. Okay. Okay. Prakrut is asking, can we deploy Spark on Microsoft Azure? No, you cannot do that on Microsoft Azure. I don't think as of now it is not supported because Microsoft is trying its level best to enter this particular big data space. And what I like about Microsoft is that they take something which is existing. They change this name, then they patent it, and then they say they invented it. So I like that pattern which Microsoft uses. So they are really trying their level best to enter into the big data space. But I'm not a very big Microsoft fan, so I cannot comment on that. I don't think they have anything. At least Spark is not interested in Microsoft. I don't know whether Microsoft is interested in Spark or not. But as far as Spark is involved, and like the Apache Foundation is involved, I don't think they really care about Microsoft. Okay, so then I have Raja asking me that what will Hive add by integrating when it's in Spark SQL? Is it not the same? No, the thing is that in Spark SQL, the thing is that the biggest advantage is that you have a good integration with Hive. So you can actually directly interface with Hive from Spark SQL, and also you can run the Hive queries. Okay, Raja? So this is the runtime architecture of Spark. If you search the web on Spark architecture, this is the diagram which you're going to get, because this diagram is prepared by the creators of Spark. So what happens is here the thing is you have something called a driver program. Okay. So what happens is so driver program is just like our main. You remember in Scala we had a main, in Java we had a main. So that's basically the entry point. So what happens is when you take a particular Spark program, so what happens is the Spark program is broken up into 2 parts. Okay. So you have a driver part and you have something called the other cluster part. So what happens is the entry point, the main, becomes a driver program, and some parts of what you write inside the code resides in the driver program. And inside the driver program, we create something called a Spark context. Okay, so the Spark context is nothing but a Spark session. So this Spark session, what happens is when you write a Spark program, what you have to do is you have to create a Spark context. Okay, I'll tell you. Don't worry about how to create and all that. Okay, so that we'll see when we write the code. But what you have to do in your program, you have to create a Spark context. And the Spark context is basically the Spark session. And this is going to do all the negotiations with the cluster manager. So what happens is after you create the Spark context directly talks to the cluster manager. Okay. And this cluster manager can be a Yarn, client can be Mesos, can be Amazon, EC2, anything. So it talks to the cluster manager. And it says that, whatever, nodes you have on your cluster, I want, these instructions to be executed on these clusters. So could you please, allocate JVM processes in each individual nodes in your cluster? So then what the cluster manager does is, assuming that, in the cluster there are 2 nodes. So in the worker nodes, it creates a process. It creates a JVM process called Executor. Okay. So far we learned 2 things. We learned a driver program, which is basically the main entry point to the Spark program. We created a Spark context. So this is basically the whole session handler from Spark. This Spark context internally talks to the cluster manager, which is available in your cluster. And this cluster manager, it says that, give me processes, create JVM processes, please, on your cluster nodes, and run them as executors. So basically what happens is then the cluster manager, creates JVM processes, and these are called executors. Once the executors are created inside, the cluster, then what happens is the cluster manager, then the Spark context basically sends the other part of the program which it wants to execute on the executors. Okay, so this part of the program where actually the cluster computing will happen, that Spark context through the cluster manager ships it to each executor. Okay, so this piece of code will go to everybody. And what happens is, then the executor internally, creates tasks, okay, which are nothing but Java threads. So it creates a lot of threads, internally, it can create any number of threads. And on these threads, this particular computation happens, okay. Now, the biggest confusion for people who already know Hadoop is that immediately they ask me, this worker node, is it the name node or the data node? Okay. So the thing is that, a lot of people ask me, this worker node you're seeing here in the cluster, is it a name node or a data node? See, the thing is that, it is neither a name node nor a data node. Name node and data node is related to HDFS. It has nothing to do with the Hadoop cluster. Please bear this in mind. A name node and a data node is to do with your HDFS. In HDFS, the metadata is stored in the name node, and the files, are distributed across the data nodes. So this may be a name node, this can be a data node, but it doesn't matter. Okay, it just doesn't matter. These are basically just cluster nodes, which the cluster manager manages. Okay. And all the bottom code, which is here. Don't worry, you may be wondering what is in the top part, what is in the bottom part. That I'll show you later when we actually learn Spark coding. But the bottom part basically stays in the driver, and the top part stays in the driver program, and the bottom part. And again, in the bottom part, what things go, that I'll tell you later. It's not that, you take the program, you divide it by 2, the top remains in the driver and the bottom goes to execute. It's not like that. The thing is that, certain instructions, which we usually write at the bottom half, goes to all the executors. They go to all the executors, okay, along with the data. And I'll tell you later how the data is sent. So, and they kind of, do all the execution. And obviously at the bottom part, finally at the last bottom, you collect the results, right? Because once you do the analysis, obviously you have to get the results, right? You just can't do the analysis and sit. So at the last part of the program, we usually collect the results and we either put it in a database or, we show it in a dashboard, something like that. So that again, happens in the driver program. And what happens is, after the stuff is done, the thing is returned back to the drivers. And the driver collects, the results and shows it, okay? So a node is an individual machine, okay? These worker nodes are like individual computers, okay, in the cluster. And Vijay is asking that what file system on worker node, like HDFS or Hadoop? It can be anything, Vijay. It can be HDFS. It can be, network file system. It can be anything. Okay, as long as it's supported by Spark. It can be a local file system also, doesn't matter. Okay, okay. Is this clear? Is this runtime architecture clear to all of you? Okay, don't worry about what is at the bottom part, what is at the top part. Those things I'll explain to you. But have you understood what a driver program is? Have you understood what a Spark context is? What how the Spark context negotiates with the cluster manager to create the JVM process? And then there are executors. These JVM processes are called executors. And then the bottom part, where you actually do the cluster computations. These are shipped to each executor, and the task is executed. And finally, the results are collected back to the driver program. Okay. And the Spark context, Venkat is asking me what is the Spark context. Don't worry what the Spark context is. Just think of it as like a Spark session. I'm going to tell you later what a Spark context is. But just for now, just take it as a session. Like when you log into your net banking or when you log into your online shopping account, you log in, so that's your user session. So using the user session, you interactions and transactions in the website, and finally you log out. So you can take the Spark context, as a kind of session, okay, for the whole Spark execution. And this whole architecture whatever I showed you is only alive till the program is running, okay? After the program has exited, So all these executor processes, will cease to exist. Don't think that these executors will, just remain there. It won't. So once the program has exited, all the executor, like the JVM processes, will exit. All the heap and everything, will be, deallocated, and the driver program will unload. Okay. So, and everything is free till you run the next program again, which will again follow the same architecture. Okay. Clear? Okay. Mohammed is asking multiple. Okay, don't worry what a cache is. Don't worry. That's what happens, when people copy paste diagrams. So I'll tell you what cache is later on. Okay, so don't worry about this cache. Okay. There are two things I'll tell you. Two more things. Just hang on. One thing before that, let me answer Mohammed's question. Mohammed is saying that multiple tasks in a single worker node. Is it a kind of representing multiple threads on a single machine? Absolutely. So these multiple tasks which you're saying here, task, these are multiple threads. Okay. So it basically, it tries to denote that executor is a multi-threaded process. Okay, Mohammed? Okay. And Venkat, don't worry about this cache stuff. Okay. I'll explain to you when we do persistence. So don't worry about this. Okay. Okay, Anand is asking, Spark is on top of Yarn, so Yarn architecture remains the same. Absolutely, Anandi. Okay, this is the Spark runtime architecture. When you're running a Spark program, this is how the architecture looks. Internally, whatever Yarn architecture you have, that is basically for the cluster manager and the worker nodes, how it negotiates with the processes and all these things, that still holds. So this is basically, you can think of it, okay, let me clear the screen, it looks like it's kind of messy now. Okay, so basically, you have your cluster manager, and this cluster manager, this architecture remains. This is your cluster manager. So this architecture remains. Okay. On top of that, you can think of Spark program executing. Okay. So this is your Spark program, and this is your Yarn cluster. So this architecture remains intact, and when this Spark program is running, this is the architecture it is following. Okay. Clear, Anandi? Okay. Rama is asking, each executor starts single or multiple tasks for a job. See, the thing is, it's on demand. Okay, so it basically starts the job, and based on the load of the work, automatically, it keeps on creating, threads. So it basically depends on, on the volume of work. If you're doing something very simple, obviously there may be 2-3 threads. If you're processing gigabytes of data, there can be 10-30 threads. And again, it's a function of how much memory you have on the worker node. Okay, so those things I'll tell you later. About the number of tasks and thread when I actually go to the configuration. Okay, but yeah, you can think of it as like it's thread on request. It gives. Okay. Vijay is asking, so Scala uses the same multi-threading concept as JVM? No, Scala doesn't use the same multi-threading concept as JVM. Don't think as these threads as the Java threads. Okay, these are not Java threads. These are something called actors. Okay, these are called Akka actors. Okay, AKKA. Okay, it's called Akka. Akka is a framework written in Scala for concurrent programming. These are Akka actors. Okay. So don't worry about what Akka actors are. If you're interested, you can just do a search. It's a good framework to learn, actually. If you, these are very seriously used in the industry. Akka. Okay. Is this clear to all of you before I just introduce you to another concept? Do you have any question in your mind? Don't worry about how executor will allocate thread. How many threads should it allocate? What if it doesn't have memory? Don't worry about all these things. Okay. This I'll tell you later. But at least on the face of it, have you understood this architecture? Can I have a quick poll from all of you, whether you've understood this or not? Any questions, please ask me. Yeah, Madhukar, I'll come to you. Madhukar, you have read my mind. That's what I was going to talk about now. But before that, just assuming that I'm going to answer that, do you have any other question? Okay, here's one interesting question. I think I answered that, Said. Said is asking that, how cluster manager decides how much the worker node needs. See, the thing is that, the Spark context basically tells the cluster manager, what is the, what should be the configuration of the executor, okay? And that I will tell you, that when you create a Spark program in the command line, you basically specify that how much of memory you want for the driver, how much of memory you want for the executors. If you don't specify anything, by default, it gives, 1 GB to the executors and half GB to the driver program. That's the default value, okay? That's what Spark sends to the cluster manager, and based on that, the cluster manager creates it. But you can override that in the command line when you run the program. But that I'll come to that later on side, okay? Just to kind of quench your curiosity, this is the answer, okay? So there are defaults. If you want, you can override the default. The default is 1 GB for executors and half GB for the driver. That's the default. Clear, Said? Okay. Now, the next thing I wanted to tell you is, okay, the defaults, Raja. Okay, the default for the executor, it's 1 GB RAM, and for the driver program, it's 512 MB RAM. So that's the default. Okay, but you can override the default. I'll show you how to do that. Okay, so I still haven't gone to the implementation. So I'll show you each and everything. So don't worry about that. There's one thing which I want to tell you is that you must have noted, or maybe Madhukar noted this and asked me, what is this? This thing. You see that the executors are talking to each other. Okay. So here basically this arrow means that this executors talk to each other. Okay, this is what the arrow means. This arrow doesn't mean that the task is talking to the cache. Okay, it just means the executors are communicating with each other. What is the scenario under which the executors will communicate with each other? People who are from the MapReduce background should know that there's a phase called shuffling, where the nodes kind of talk to each other and shuffle data. So say, for example, if you're doing some kind of processing, and after the processing, what happens is, the executors kind of exchange data. Okay. So that's called the shuffling phase where say, for example, you have a data which is a key value pair data. Okay. And suppose you're doing some kind of processing on that. So what usually Spark tries to do is that, after the processing, it tries to bring all the keys of similar values or similar range to the same executors, so that, the processing becomes much faster. So to do that, obviously they have to talk to each other and just kind of communicate to exchange, the relevant data from each other. So that's similar to the shuffling. And that's why, executors talk to each other, where, all the similar data are brought to one executors, so that, any kind of aggregation, if you're doing, will be much faster. And we are going to see that, when we do key value pair stuff, okay? So that is what the executors. Just remember for now that the executors do talk to each other, especially if they're doing some kind of shuffling of data. Okay? So any more questions on this? Yes, Anandi is making a comment. She's saying that the way Yarn handles the MapReduce program, is it different from Spark? Yes, it is different. The way the handshaking happens. See, the way a MapReduce runs on Yarn and the way a Spark program runs on Yarn, obviously this is called a handshaking process. Obviously, the handshaking process will be different. Okay, it is different from the way it handles. Vijay is asking that what other things are there on the worker node. See, from the Spark context, there's only the executor. In terms of the cluster manager, if this is a Hadoop, you can on the worker node there can be data nodes, and there can be other things also running. Okay. So, but as far as the Spark is concerned, only the executor is there. That's it. Okay. Okay, now let's, a lot of people were asking me what a Spark context is. So here is the Spark context. So the Spark, the Spark applications runs at separate processes on the cluster that I showed you, as executors. And, all the distributed processes are coordinated by the Spark context, which sits in the driver program. Okay. So everything is kind of controlled by the Spark context, which sits in the driver program. And the Spark context, is the chief negotiator on behalf of on behalf of Spark to the cluster manager. Okay. So Spark object, the Spark context, it connects to the cluster manager, whether it's a standalone cluster or a yarn or mesos, and and asks for the resource allocation across the clusters for the executors. So the cluster manager, provides executors, which are essentially JVM, to run the logic and provide heap and stack data. So, and then what happens is, then the Spark object, then the Spark context, as I told you, takes the object code, the one which is to be executed on the clusters, and sends it as as jars or as Python scripts to the executors. And finally, the Spark context executes. Then it actually it doesn't execute. The executors executes the task, and finally, then the Spark context is deallocated. So basically, it's a summary of whatever I have been telling you in the previous diagram. But the Spark context is the most important thing. Without that, you cannot really do anything in Spark. Okay, that's the entry point to the whole Spark programming, because that's where the negotiation starts with the cluster manager. Okay, Shankar is asking, is Spark context similar to Q sub? What is this, Shankar? Sorry, man. I'm pretty bad at these abbreviations. There are so many, and okay. So I remember somebody asking me that how does Spark fit into this whole Hadoop ecosystem, or into this whole big data stuff. See, the thing is, if you look at the Hadoop 2.0, stack, this is just a high level. Okay, Prakrut is asking that, does Spark context, in the previous slide, there was a thing that, does Spark context send the Python jar file or binary code? See, the thing is that, the jar file itself, they are binary code, they are the byte code. The jar file, they have, the byte code, that is the class files. So that's in binary format. And obviously the jar is, it's compressed. So you can send it faster. Okay. And similarly for Python script, it generates the precompiled, the Python. It doesn't send the text file as it is, it compiles the Python code and sends it across. So if you're running a Python script and if you make a syntax error, you will see that when you submit the job, immediately you will get, the error, the syntax error or some kind of error, because what it does is, the Spark immediately tries to compile the Python code and then send across the Python binary. Okay. Okay, Shankar is asking, this is for submitting to SGE cluster where we tell how many nodes we want to analyze. See, Shankar, I'm not aware of this SGE cluster. I won't be able to help you. Maybe, you can ask somebody in your work, or maybe you can just post a question to Stack Overflow. If somebody has experience in the Sun, clusters, they will be able to help you. I think you can just post it to the Stack Overflow, okay? Because I don't have expertise in this area. Sorry about that. I can help you with Mesos or Yarn or Amazon, but I haven't worked on that. Okay. Okay, good. So I remember somebody asking me how does Spark fit into this whole stuff. So the thing is that, Spark, how it happens is, you have this Hadoop 2.0 where you start with the HDFS, the basic file system. So let's start from the bottom. So we have the HDFS, and then we have Yarn, which is the cluster manager, and then we have the MapReduce framework, and on top of that you have, Hive and Piglet, and you have other Yarn based frameworks like MPI. I don't know what MPI is. Anyway, I know what Giraffe is. And then also you have HBase, and then you have Woozy for workflow management. Now the thing is that, this is a typical Hadoop stack, and what happens is, and the thing is, oh yeah, right, this This is the message passing interface. Yeah, I'm so sorry. I keep forgetting the abbreviations. Yeah, that's the messaging interface for Hadoop. So now, you have the Spark ecosystem. This is where, see, the thing is that, if you look into the whole big data stuff, you have execution engines. So the thing is that, if you look at the batch level execution engines, you have Tez, you can use Spark also, you can use Pig, you can use MR, MapReduce version 1 or 2. Similarly, if you're doing any kind of machine learning or graph-based processing, you can use GraphX, Mahout, MLlib, or Giraffe. Similarly, if you're using SQL, you can use Drill, Impala, Hive, or Spark SQL. And if you're doing NoSQL stuff, you can use, HBase, Cassandra, and other stuff. And similarly, for streaming, you can use Flink, Storm, or you can use Spark Streaming. And similarly, these are the other stuff which you have, for in the whole ecosystem. So as you can see, for each feature, one sec. So as you can see, for each feature, whether it's batch or SQL or, you have various software which are available to you. And, you can choose the one which you want, because I won't say this is better than that. It all depends on your requirement. There are situations where I think Storm really stands out, compared to streaming. So you have to see your use case, how you want to use it. So this is how Spark kind of fits in, in the batch, or even in real-time streaming. You can use the Spark streaming and the Spark core libraries. In ML and machine learning and graph-based processing, you can use these libraries. For semi-structured and structured data analysis, you can use Spark SQL. So that's how it fits into the whole big data ecosystem. Okay, is this clear? I think somebody had asked this question. So now you know how Spark fits in, where each of the component fits in. Okay, here Shankar is asking, what does the star, I really don't know what the star, implement, because usually, if you put a star, basic courtesy says that, you have to mention what it means at the bottom, rather than letting the, user guess what it means. So since the person, hasn't given the index, so I assume that he has given the star for decoration. Vijay is asking, can you tell me where is Spark used these days? Spark is used everywhere. This diagram is very relevant because it's everywhere. You can use it in streaming, and even in the new version of Apache Spark, that is version 2. It's still a preview release. They have really revamped this whole Spark SQL, and I see a lot of traction there, and I expect a lot of popularity going in the coming days. Okay, I mean, it's going to become very popular. And similarly, MLlib is also picking up pretty well. So it all depends, And Kafka, somebody is asking, where does Kafka fit in? Kafka should be a new line. It's in the messaging. So if you create another new vertical, if you create a new vertical here, so if you create a new vertical here called messaging, this is where Kafka sits in. Kafka or RabbitMQ or message queue, other stuff. That's where it sits in. Okay. So the Spark can use Hadoop storage. Spark not only is limited to HDFS, it only needs the HDFS for storage. And we all know that HDFS, is used for large storage of large data sets. It is high availability, and you can run it on commodity hardware. And Spark is compatible with 1.x, though the preferred, thing is 2.x. And if you're just using HDFS as a storage in Spark, if you're not using the cluster manager, that is, if you're not using Yarn, but if you just want to use the HDFS to dump files, then you can just use Hadoop 1.x. But if you want to use the Yarn, as a cluster manager, then you have to use Hadoop 2.x. Okay. And obviously, we know how how HDFS handles data loss and reliability. And if you look at the Yarn, as the execution engine, so Spark can be executed on Yarn. And like other cluster managers, and Yarn automatically provides processing scalability to Spark. That we all know that is the advantage of the Spark of the Yarn architecture. And Spark needs as I told you, Hadoop 2. Version 2 and above for if you want to use the cluster manager. And every node in Hadoop cluster, just remember that if you're using Hadoop, so every node in the Hadoop cluster should have the Spark installed. Okay, otherwise it won't find the Spark it won't be able to find the Spark libraries. So if you're using the Hadoop Yarn cluster, make sure that on all the Yarn cluster nodes your Spark is installed. Okay. And obviously, if you're running Spark processes on Hadoop cluster, you have to upgrade your RAM. That's quite a no-brainer because you need more RAM on that. So RDDs, the short form of resilient distributed data set, it's called RDD. So this RDD, it's the fundamental, programming abstraction in Spark is RDD. So if you want to do any kind of programming on Spark, basically you have to use an RDD because RDDs are, the entry points, the starting point for any kind of programming. Okay. So just remember that the fundamental abstraction of programming in Spark are RDDs, okay, resilient distributed data set. And always remember that RDDs are immutable. That means once you create an RDD, you cannot change an RDD, okay? You can only create new RDDs out of it by transformation, and you won't be able to change the existing RDD. So say, for example, you have a particular data set, and let me just draw a diagram. So say, for example, you have a particular data set. Now, from a data set, you generate an RDD. So that's basically the basic programming abstraction in Spark. And once you have this RDD, you can do a bunch of transformations on it. Okay, transformation means any kind of transformation. So say, for example, one transformation example I can give you is say, for example, you have a function, and say, for example, you have a function of x, which is say which is just x plus 2. Okay. So this is a very basic function where the function equals x plus 2. Now, any kind of transformation on the function, you can have defined another function gx, which is nothing but 2 into fx. So that's a transformation. So we can say that gx is transformed. Sorry, fx is transformed to gx. So always remember that transformation is basically any kind of change which you do in the function. So on RDDs we can only do transformations, and and obviously when we do a transformation, a new RDD is created, so the initial RDD remains intact. Okay. And the second thing, just remember that so the first thing is that we can only do transformations on RDDs. And the second thing which we can do on RDDs are actions, okay, which is actually, some particular action. We'll see what actions are, what transformations are in a minute. But always remember, firstly, what a transformation is. So if somebody asks you what a transformation is, I think you can give this example. And so RDDs, you can only do two types of operations, transformations and actions, okay. And we are going to see more examples of, transformation and actions in a short while. And also one thing you should remember that for example, if you're doing a series of transformation, okay, Prakrut is asking that when did the session start? We started sharp at 9 o'clock. At 7 o'clock Indian Standard Time. So in case you missed it, you can just catch up with the recording. Okay, just 5 minutes ago. Okay. So I just explained, what an RDD is. So a basic programming abstraction in Spark is called an RDD. RDDs are, always remember that RDDs are mutable. So you cannot change any RDDs, okay? And the two types of operations which you can do on RDDs are, either transformations or actions, okay? And transformation, what does transformation mean? So say, for example, you have a function called, fx, called x plus 2. So a transformation on that will be just if you say, for example, if you multiply, the function fx by 2, or if you do some kind of other mathematical operation. So that's basically a transformation on the function. And whenever you do any kind of transformation, a new RDD is always created. Okay? So that's one. And the second thing is that, RDDs are, so let's understand, what RDDs are a little bit more fundamentally. Okay? So let me just clear this board. And There are too many things on the screen. Okay. So, I'll come to that, Ramesh. Ramesh is asking what actually RDD contains. First, let's understand, first let's understand a couple of more concepts before I go into an RDD, what it contains and how it looks, okay? So, say for example, you have a function. Let's take this particular function, so we have this function fx, which is, x plus 2. And then we do a transformation, say, gx, which is 2 into fx. And, then we do another transformation. So these are all, transformations. So then we do another transformation, say, for example, hx, which is, maybe, you take gx and, you square it. Okay. You, for example, square it. Okay. So, and like that, you can have series of transformations. Now, when you do transformations in Spark, what happens is that, the compiler, the Spark runtime compiler, what it does is, it generates directed acyclic graphs or called DAGs. Okay. Shankar is saying that, can I say gx equals fx? Well, then that's not a transformation. If you do a gx equals fx, that's actually not a transformation. Okay. We'll see later why it's not a transformation, because, if you just give the function the same, so you are just reassigning the function, to another function. So, which is not mathematically a transformation. Okay. It is just a reassignment. Clear, Shankar? Shankar was asking that if I do a gx equals fx, so in that case, is it a transformation? So Shankar, agrees with my answer, but he's saying that what if I want to reassign? You want to reassign, in Spark we'll see that, we rarely reassign, RDDs. So we only take the RDD and, we do only do transformations on that. There will be no use cases where we would like to reassign, because reassigning, it really doesn't serve any programming purpose for us. An action is basically, we are just going to see the action, but first let's understand what transformation is. Okay, just be with me, don't jump the gun, and just try to follow the concepts which I'm giving you one at a time. Okay, so I'll explain to you what an action is, but before understanding an action, you have to understand what a transformation is. Okay. So first, have you understood, this series of transformation I'm doing? Okay. Have you all understood this? So you have a function fx, and then, you transform fx to gx, and then gx to hx. Like that, you may be doing a series of transformation. Is this clear to all of you, the series of transformation? Okay. Can I have a quick, response from all of you, whether you have understood this or not? Because this is very fundamental, don't try to go ahead of time, just be with me, because I'm going to explain to you everything. But let's understand what transformation action is. Okay, so now what we are going to do is, what the Spark compiler does is that, it generates a DAG, okay? It generates a directed acyclic graph. So what it does is, it generates a DAG. So the first DAG, it contains, fx, and then compiler says that, fx is, transformed into gx, okay? And then, gx is, transformed into hx, okay? Okay, and so then we do an fx, and these are all lazy evaluations. So that means, actually fx or actually gx or actually hx, that's what I'm doing, Shankar. Folks, this is what I'm explaining, what a DAG is. Oh, you want to know fundamentally what a DAG is? Okay, a DAG is a directed acyclic graphs. Okay, what do you mean by directed acyclic graphs? So say for example, you are right now in London. So suppose I'm drawing a route map, and suppose you have gone to Europe for a vacation with your family, and this is your tour plan. So first you will go to London, you land in London. So from London you will go to Edinburgh, which is the capital of Scotland. From Edinburgh you are going to go to Paris, and from Paris you are going to go to Frankfurt. Sorry, not Frankfurt. You will go to Berlin, and from Berlin you will go to a place called called Interlaken in Switzerland, and after that you will go home. So if I want to draw a tour plan, so I'll say from London you go to Edinburgh, from Edinburgh you go to Paris, from Paris you come to Berlin, and from Berlin you come to Interlaken, and then finally you go home. Okay, so if I want to if I want to show a route map like this, then this is a typical classic example of a directed acyclic graph. So why it is directed? Because the direction is given. There is a clear direction from one node to another, and these are called nodes, and these are called edges. So these are nodes, and these are called edges of a graph. I think these are very fundamental graph concepts, and this is a directed acyclic graph. And why it is acyclic? Because there is no cycle. Okay, if again from Interlaken you came back to London, then it would have become a cyclic graph. But this is not a cycle, okay, because there is no cycle here. That's why it is cyclic. Okay. So that's why we call it a directed. That means there is a direction from one node to another. It's a cyclic because there is no cycle here. And obviously it's a graph because it has nodes and edges. So all of you clear what directed acyclic graphs are? Okay, good. So now what happens is, okay, one sec, we have a question from Said. Okay, Said, I'll come to your question. Just be with me for a while. The thing is that you generate so what happens is that the Spark compiler generates a DAG, and these are all lazy values. Okay, can you all hear me? There was a little bit of a network problem, and we lost the video for a while. So okay, we can't help that. That's unfortunately beyond our control. So that's the reliability of network. Okay. So what happens is I didn't say anything because I could see that the network the voice was lost. So I kind of kept shut. So what I was saying is that it does a lazy evaluation. Okay. And just because it does a lazy evaluation, no actual calculation happens unless we do a real action on it. So now if I call, say for example, now if I say that evaluate hx, say for example if I make a call like evaluate hx, this is basically what an action is. Okay, so action basically in Spark means that that's when actually the DAG is going to be evaluated. So what happens is when I call a particular action, there are a couple of functions which falls under the category of evaluation. So in Spark you will see that I'll tell you as we go along, that there are a bunch of functions which are transformation functions, and there are a bunch of functions which are action functions. So action functions means that actually the DAG will be evaluated. So say for example if I call an arbitrary function like evaluate hx, so then what happens is that this is an action, and what Spark does is it basically evaluates all the functions from the beginning of the DAG. So it will first calculate fx, from fx it will generate gx, from gx it will generate hx, and then return the results. Okay, so that's how basically how the transformation generates a DAG, and when you do an action on it, the actual DAG gets evaluated. Now, is this concept clear of just transformation and action? Is this concept clear to you? Then I'll take all your questions. Just tell me whether this is clear or not. Don't get into yeah, Ramesh, tell me what you didn't understand. Okay, let me just pay attention, folks. Okay, because if you don't understand this, I don't think you'll really have a problem in understanding the whole concept of Spark. So the thing is that we have, say for example, we have a particular function called fx equals to x plus 2. Okay, and just try to understand first what I'm saying. If your mind is already cluttered with questions, I suggest you just clear that out for a minute, because just give me some time. All your concepts will be clear. Okay, first let's understand mathematically what a transformation and an action is. Okay, let's keep Spark out of this for a while. Okay, so we have a function called fx, which is where the function is defined as x plus 2. Now we can do a transformation where we just multiply fx with 2, and then you will end up with a function called actually it's a better way of writing it is we can do. So a better way of writing this is that we can define another function gx, which is nothing but we take fx and just multiply x by 2, so we get another function. Then we can define another set of transformation where we square gx and we just square the function, and we get another function called hx. Okay, so what we are doing is at every step, we are taking the function and we are transforming it. We are mathematically transforming it to another function. So that is basically what we call, a transformation in mathematics. Is this clear, Ramesh and people who didn't understand this? Is this part clear to all of you? No, transformation basically, transformation means that, I am, mathematically transformation means that, I'm just doing a definition. This is just a definition. This does not necessarily mean an evaluation. Okay, when you define a function, that does not mean the function gets evaluated. Okay, the function only gets evaluated, when you actually call the function. Okay, so this is just a definition of the function, which is a transformation definition. Is this clear, Ramesh? So we are just defining, a transformation. So that's what a transformation is. There is actually nothing happening here. We have just defined that what it is. It's just like defining a variable. Okay, so unless you actually, access the variable. Okay, Ramesh is saying that transformation happens because of, because of some action. No, see, the thing is that, I don't know, you are probably getting confused, with things like, you are thinking this +2 when I'm doing a +2, when I'm doing and multiplied by 2, you are thinking these as actions. These are not actions, these are, I'm just defining it, so it's just a definition. Just don't, please don't, please don't add your own, interpretations of actions. Here, this is just a definition I'm doing. So you have an fx, which is x +2. And, I just define another function, gx, which is nothing but fx into 2. Okay? So it's just like you're defining, like in traits we saw, we were defining traits. So here also, we are defining, we are also just defining a function. And what basically Spark does is that, the compiler basically generates a DAG out of it, So these are all lazy evaluations. So it generates a DAG like this. First you create an fx. From fx you go to gx, and from gx you go to hx. So a DAG is generated. And, these are all lazy evaluations. That means the functions, are actually not calculated. So that's why, you generate a DAG out of it. So in Spark, when you do an action, there are a couple of functions, which falls in the category of actions. Action means that where actually the DAG gets evaluated. Okay, so there's a difference between definition and actual evaluation. So this is the place where you define, and this is the place, where you actually do an action. So when you just say evaluate hx, so that's when, the Spark evaluates, all the functions from the beginning. So it evaluates the fx, and from fx it transforms into gx. Gx gets transformed into hx, and finally you get the result. And that is exactly what, the whole architecture of Spark works on. There's something called DAG, okay, lazy DAG evaluation. So that means, it generates a DAG for all the transformations, and from there it generates, if you do any kind of action, and we'll see what actions are, what are the types of functions which fall under actions. So that's when, your actual DAG gets evaluated and you get the result. Is this clear now? Okay, don't worry if you haven't understood, when we see the code, because, probably I introduced too much of mathematics and that confused people. So don't worry about it, when you see the code, you will automatically understand what actions are. So just remember for the moment that, let's understand, why the compiler generates a DAG out of it. So why there is a lazy evaluation on transformations. So once you actually see the code, if people can't hear, I suggest, they please reconnect. There may be a problem with the network. So, because I think others can hear me. So can others hear me? Okay, so, people can hear me. So people who can't hear me, I think there's a network problem for them. So I suggest, you kindly break off and, just log out and log in again. I think things will be fine. So now let's understand, why the compiler, why the, Scala, why the Spark compiler, generates a DAG out of it. We all know that, in cluster computing, any kind of computation is very, very expensive. Okay. So what Spark does, it tries to postpone any computations to the last responsible moment. till any actions are done on it. Okay, so what it does is, when you actually do any kind of transformation, so Spark does a lazy evaluation, and it doesn't straight away compute the function values or the transformation values, because only when you do some action on it, only we'll see later, what kind of functions are in the class or function in the classification of action. Only when they do some action on it, that's when the DAG gets evaluated, and that's how in cluster computing they optimize all the calculations. Okay, so that's how Spark optimizes the cluster computing overhead. So because any transformation you do, Spark immediately does not land up do calculating it, because finally what you want, that's what Spark is interested in. So when you say when you do an action, and that's when you actually say what you want from the RDD, that's when your whole DAG gets evaluated, and that way it just optimizes the whole network computation. Okay. And another thing, please remember that by resilient, when we say resilient distributed data sets, by resilient I mean it is fault tolerant. So what do we mean by fault tolerance? It means that if Prakrut, I think there is some problem with your network, because other people can hear me, and so if others can hear me and you cannot hear me, then probably it's a problem with your network. Okay, so people who cannot hear me well, maybe a problem with your network, because others can hear absolutely loud and clear. So one thing you remember that they are resilient in the sense that the compiler, as I said, that generates a DAG out of it. So in case and these DAGs are sent to all the all the nodes, which we are going to see in a short while. So what happens is in case there is a failure, in case there is a node failure, what the compiler does is it just resends the DAG again to the particular node, and the node can just replay the DAG and get the state of the data. Okay, so it's just like a set of macros, which becomes very useful when we want to recreate what was already there. So we can just replay this and get back the state from where we were. So it just gives you the map of how things happen. So the compiler resends it to the node, and you can just replay the DAG and get the value. So now let's look at the piece of code. I think then things will be pretty clear to all of you. So what happens here? If you go to my GitHub, you will see a Spark dev directory. So that's where we have all our Spark. I have my Spark samples. Whatever I'm showing you, you can just download it and play around with it. So let's do a simple word count. I think people who are from a Hadoop background, MapReduce background, must have done the word count samples a lot. So here we're going to do the same stuff, with Spark. So what happens is, I have, this is how you write your program. So you write a Scala file, word count.scala, and what we do is, we write the word count, object word count, and in the main function, we define a main function. What we are doing is, this is how you write a function. So first what we do is, we create something called, Ramesh, were you there yesterday? Because yesterday the whole class, we discussed the Spark architecture. So were you there yesterday? In case you were not there, I'm sorry, I won't be able to repeat the Spark architecture. You have to go through yesterday's video, because we have to do proper time management, and I'm sorry I cannot repeat on things where I've already spent considerable time. So what happens is, first what we have to do is, we have to create a Spark configuration. And Spark configuration, what it does is, it's basically a simple configuration reader. And what internally happens, let's find out what internally happens when you create a Spark config. Because here, I'm just doing a code walkthrough, so each and every step you're going to understand. So if you go to the Spark, installation in your wherever you've installed it. So if you go to the configuration directory, okay, so this is where you have a bunch of configuration files, where basically it finds out, all the default values, what it's needed, to start Spark, and things like that. So when you do a Spark configuration, so when you create a new class, what happens is, this class reads the configuration folders and finds out, all the default configurations, okay? And we are going to see later how we can override the configurations. And so that's what we do. And after that, we set the application name. So what happens is, when the Spark job is running, we have to give it a name. So here what I do is, on the Spark configuration, I set the application name as, word count job. And then what I do is, with this particular configuration, I create a Spark context. Okay. So yesterday we spoke about Spark context, a lot. And so this is how you create a Spark context. So this is the chief negotiator with the, with the cluster manager. So here what I do is, I create a Spark context. And in this context, I pass the configuration. So a new session of Spark is created, with the configuration, whatever is there, the default configuration, and it starts negotiating with the cluster manager. Okay? Are these two lines clear to all of you? Okay, Nitin is asking to read the default configuration. Should we include any file in the project? No, you don't have to do anything, because automatically Spark figures out when you run the Spark job, automatically it knows where the configuration file is. I'll show you how to run the program. So it'll know the configuration directory and will figure out from there. Okay. So what happens is, when the moment you create the configuration Spark config, when you create a Spark config class, the Spark config straight away this class internally will read the configuration, default configuration files. Okay, and using that configuration we create a Spark context. Clear, Shankar? So, and yesterday I explained to you what the Spark context does, so we have a Spark context ready. Okay. So now what we do is, we define a file name. This is the file name which we want to read. You can read any file source. This is, if you give a thing like this, it means that I'm going to read, I'm going to read it from my local file system. So I'm going to read the, readme dot, markdown document of the Spark installation folder. So this is the file I'm going to read. So this is the file I'm going to read. That's just the readme dot file. So this is the file I'm going to read from Spark. Okay. So this is the file name I've given, and the thing is that the package which we have to include is basically org.apache.spark, Spark context and Spark config. So if you are importing multiple classes from the same package, you can write it like this, in braces. You can write the class name separated by comma. So these are the two classes I import, and then I declare a file name. Okay. And then what I do is, on the Spark context, there's a method called text file, okay, and I read the text file, okay. So I call the method text file, and it takes the file name, which returns a file. Now what we do is, this is the program which I've written in the IDE. Now what I'll do is, let me execute that in the Spark shell. And why I want to do that, because then every step you will understand. You will also understand the return values, what's happening here. Okay. So the Spark shell, if you want to start the Spark shell, just go to the Spark installation folder and write Spark-shell. So this will start the Spark shell, the interactive REPL shell for Scala. Okay. So we saw the Scala shell. So this is just REPL shell for Scala. This is the same REPL shell for Spark, where you can do Spark programming. Okay, so we start the Spark shell, and we define a variable file. Okay, sorry, okay, file name is not there. Okay, so we first define the file name, and then we read the file. Okay, and once you read the file, you will see why I'm executing that in the Spark shell is because at every step you will see what has been returned. So the file which you read, this particular variable, you see that it is of type org.apache.spark.resilient distributed dataset. Okay, so this is basically in the package spark.rdd, and basically it returns an RDD of strings. So that means it has read the file line by line, and it has returned you an RDD of strings. Okay, so it's a resilient distributed dataset of strings. And what happens is when you read this particular file, an RDD gets created. Okay, so this is a simple transformation I'm doing where it generates an RDD, and this RDD is distributed across your cluster. Okay, so you have your cluster, and when Spark starts, automatically it knows where all your clusters are. So this RDD, the data in the RDD, somebody asked me, I remember that how the data gets, how the data is there in the RDD. So what happens is the file is read, and the data is replaced. It's set across all the all the clusters. So the data is distributed. So if you see the contents of the file, you will see that this is an RDD, and it's an RDD of strings, and it has it has all the file contents. And if you want to read an RDD, you can use a collect function, okay? But never use the collect function because collect means that you basically just show all the input in the RDD, and so this is what it does. It will show all the contents of the RDD, and obviously it shows all the lines of the file which we read. Now the thing is that why you should not use this file is because, say for example, you have read a file which is of size, say 100 gigabytes. So in that case, if you do a collect, then your program can crash. Your VM can go out of memory because it won't be able to hold so much of data. So what we usually do is, in real life, we don't do collect. If you do collect, you will be in trouble. So what we do is, we just take maybe the first 3 records or 4 records or 10 records and just see what the contents are. So we saw that, the contents is basically an array of strings. So each line has now become a string, an array element, and that's how it is stored. And a lot of people are asking me questions, so I'll take one question at a time. The first question is that, let me see, what is the first question? The first question is that Ramesh is asking that I see a replication factor there. What is a replication factor? Okay. So, okay, Ramesh, I'm just curious, where did you see the replication factor? Okay, Ramesh, the thing is that, I cannot answer this question because I still haven't discussed replication factors, so you have to just hang on for a moment, okay? So let's kind of stick to what I'm doing now. So I'll answer your question. Okay, Shankar is asking that, so how do we know how many nodes are there? See, I'm using, the default, installation, which is there in the Spark VM. It basically has, one master and one node, okay? So that's what, the installation is. And when you're working on a Spark cluster, obviously, you will know how many nodes are there. So here, basically, we have one master and one node. So that's what it is working on in the VM, okay? And Mohammed is asking that, is there a limit on the file size that it can be read into RDD? No, Mohammed, there is practically no limit. As much as memory you have, it can read. So if you have, memory that can accommodate 1 terabytes or 2 terabytes of data, it can read, not a problem, okay? And we don't put anything, in the Spark context. The Spark context, it's purely a negotiator with the, with the cluster manager. This we usually put it in the default, in the configuration. So the default configuration, if you remember, I told you that, for the executors, it is 1 GB memory, and for the driver, it is 512 MB. And if you want, you can override that. So I can always override it later on when I want. Okay? Okay, so no, Venkat, I'm not creating any configuration file. The thing is that in this piece of code, I'm just reading the default configuration. That is the default configuration for each Spark job, which is already defined in the configuration folder. And I'm just creating a Spark context out of it. Okay? And Shankar is asking that if there are 4 nodes, then what happens? The 4 nodes, then what it does is, it just distributes equally the data into all the 4 nodes based on the memory available. And all this, all this data is in the RAM right now. And so how big RAM you should have, purely depends on the data you're handling. And that's the call you should take. Because if you're dealing terabytes of file, then obviously, you have to make sure that, you have so much memory. You just can't run it on your laptop and expect things to work. So you should have that much of memory also available, okay? Yes, when I say take 3, basically I read 3 nodes, okay? So what happens is, when I create an RDD, so what happens is, if say for example, taking Shankar's example, if there are 4 nodes, So what happens is, there is only one RDD which is created, and what happens is, this RDD data is distributed across 4 nodes. So what happens is, suppose there are 4 nodes in the computer, in the cluster. So if there are 4 nodes here, so what happens is, after reading the RDD data, the DAG, it's distributed across this 4 nodes. So it doesn't mean that 4 RDDs are created. It's just that the copy of RDD with split where the data is split and sent across the 4 nodes here. And people, you wanted to know, because say for example, if you when we do a particular transformation, so this is a typical transformation, okay. So when I read a file, it creates an RDD. So this is a transformation, because if you look into only a DAG is generated out of it. There is no actual computation, okay. So only a DAG is generated, and the DAG says that, read the text file with this particular name. So actually no computation happens. The computation only happens when we call a function like, take. So when we take the first 3 rows of this RDD, that's when the actual DAG will be computed, and you are going to get the results. So this is an example of a transformation, and this is an example of an action, okay. And the splitting of the data, it's purely done by Spark. It uses an intelligent algorithm to split the data and distribute it across the cluster nodes, okay. So this basically starts the master instance on the machine on which the script is executed. And if you want to start the slaves, that's where you execute the slaves script on the slave machines. So this is going to start the slave instance on each machine specified in the configuration file. So in the configuration directory, you have a slave configuration where you write the IP of the nodes which you want to be slaves. So when you start the slave, when you execute this particular shell script, what happens is that this particular script communicates with that particular server over there, to that particular computer node, and starts a slave over there. So you can start all the slaves by using this particular start slaves, or you can run an individual slave using a start slave shell script. And you can also give a start all, which basically starts, which internally calls the start master and the start slaves. And then you can call a stop master, stop slave to individually stop the processes. And you can also do a stop all, which stops the slaves and the masters. So that's the launch Spark script, and you can also I'll also give you a demo on how you can run the Spark standalone cluster. So that's basically very good for testing. So what we do is we just let me close this. So what we we go to the Spark and then we say start master.sh. So what it does is it started the Spark master, and if you do a JVM process monitoring, you will see that the Spark submit and Spark master, they are all running. And then you can similarly start the Spark slave. There's no point in running slaves because I'm just running it on my computer, so it starts the slave process. And if you do again a JVM process status, you will see that it has started the master and the worker. And if you want to see the shell, you can go to the shell and you can see whether the UI has started or not. And Ramesh is asking that if you want to start everything, that's what we use, Ramesh, the start all script, which I said before. You can use that. And now you can actually see this one. You can just go to localhost and you can give 8080. And you will be able to see the Spark cluster which is running. Okay, and you'll be able to see the worker node as well, because I started the worker node and this is what it is doing. And if you run any task here, you'll be able to see the tasks.